Isomerism. This isomerism classification mainly structural isomerism or constitutional isomerism and stereoisomerism. In this stereoisomerism, again two types, configurational and conformational. This configurational again two types, geometrical and optical. In the last classes we discussed first structural, then geometrical, then optical over. Now today class is about conformational isomerism. Yes, how it is forming due to CC bond rotation. Okay, now we will discuss clearly about conformational isomerism. So this is the conformational isomerism due to CC bond rotation. See the definition. The different arrangement of atoms in space that result from the free rotation around CC bond axis are called conformations. The phenomenon is called conformational isomerism. Okay, see here this CC bond is there, this CC bond rotation. Okay, theta. So if you rotate 1 degree also another conformation, 2 degrees, 3 degrees, 2.5 degrees, 3.12 degrees. So like that you will get infinity isomers. Okay, this infinity isomers are called skew conformations. These are skew conformers, skew conformational isomers. Okay, we don't discuss all these infinities conformations. We will discuss only two which are important. One is eclipsed and one is staggered. Okay, first here one word is a dihedral angle. What is this dihedral angle? So the angle between two planes. Suppose here this is the one CH bond is there, and in this CH bond what is exactly backside is there, so theta equal to 0 degrees. But here you can see this one and this one. So if you take it like this hydrogen here, so this one, this is the theta. Okay, see that means first carbon this hydrogen and the backside carbon hydrogen, in between these two hydrogens the angle that is called dihedral angle. Okay, next, which of the following show conformational isomerism? So for the conformational isomerism, minimum 3 continuous sigma bonds is required. So 2 carbons generally. So here this it cannot form conformational isomerism. So here 1, 2, 3 bonds are there. So conformational isomerism is possible. Here it's not possible. Here continuous 3 are there. So here lone pair is there. It's okay. But 1, 2, 3 bonds are there means it's possible. 5th possible. Then 6th also possible. Now, if we take one molecule, ethane, in the ethane, how these conformations are there? So, this ethane, this is the Sahar's projection. In the 3-dimensionally, we can show like this Sahar's projection. So, just you can write one. It is a Y, inverted Y shape, and other one is Y shape. You can write it. Okay, this you can connect this center. So these all are hydrogens, inverted Y and Y, right? So this is the Sahar's projection. Now to explain this conformational, we have to keep it one carbon is stable, fixed. The other carbon should be rotate slowly. So per every 1 degree and per every small rotation, it is giving a new conformations. So these are forming infinity conformational isomers. So in that the main important is, so the first one is here theta equal to 0. Actually, this front hydrogen backside, exactly backside, this back hydrogen is there. If I write backside exactly, you cannot able to see that hydrogen is there or not. That's why we are showing little bit slight side. Okay, but you have to assume exactly backside. Now, so this hydrogen we are rotating. This hydrogen, first of all, this dot is first carbon, this ring is second carbon. Okay, the second carbon, backside carbon, rotating 60 degrees. 60 degrees I'm rotating. Then front carbon is fixed. So now what is the dihedral angle here? Theta equal to 60 degrees. Now you understood clearly what is the dihedral angle. Dihedral angle means the front carbon is CH bond. So H, C and another C and another H. The first carbon and second carbon. First carbon CH bond and second carbon CH bond. In between these two sigma bonds, the bond angle is called dihedral angle. Right? Now, so exactly if it is backside is there, this is called eclipsed form. Okay, in the last slide we saw that sawhorse projection. One is Y shape and inverted Y shape. Okay, so this is called Newman projection. This is called Newman projection. We are showing in the Newman projection, the dot is indicating one carbon, ring is indicating another carbon, backside carbon. So if the front hydrogen backside, exactly backside hydrogen is there, that is called eclipsed. You know the meaning, English meaning eclipsed means sun eclipse, moon eclipse. Yes. So eclipse means exactly backside is there, shadow. So then staggered means maximum away from each other. Okay, that is possible at 60 degrees only. You may think, sir, what about 70 degrees? If you take 70 degrees, assume that I am taking here, it is hydrogen 70 degrees. In that case, again, it will be, what is the 50 degrees? Because here in between total 120. So it is nearer. So sterically free, maximum away from this front CH bonds, that is possible only at 60 degrees. At 60 degrees. That is stable conformation. That is stable conformation. That is also known as staggered conformation. That is also known as staggered conformations. Now, what about stability? The stability always staggered is maximum stable, that is theta equal 60 degrees. Then skew means so many different, and eclipsed is here theta equal to 0 degrees. Exactly backside is there. So why eclipse is less stable than staggered? Here we know the dihedral angle. So here two types of repulsions are there. Two types of repulsions. See here, here one sigma bond is there, CH bond, the back side another CH bond is there. Front CH bond, exactly back, here also CH bond is there. So these two electrons and two electrons, sigma bond electrons, obviously negative charge. Okay, due to that negative charge electron cloud, this electron cloud and this electron cloud repel each other. Repel each other. This is called torsional strain. You can see here torsional strain. This is the one. The second thing is here hydrogen, exactly backside hydrogen is there, means that is the nearest, less distance. So here van der Waal repulsions, group repulsions, steric hindrance we can say. Steric strain. Steric strain, van der Waal repulsions we can say. Okay. Now due to these two repulsions, this is very unstable. Which strains? Torsional strain and steric strain. Due to sigma electrons is called torsional strain. Due to big bulky groups, that is steric strain repulsions, right? So due to these two reasons, eclipsed is unstable. Unstable means always higher energy. It is an energy level diagram. So unstable kabhi bhi higher energy. Unstable equal to high energy. Okay, high energy. So eclipsed is higher energy than staggered after 60 degrees. Here theta equal to 0 degrees. Here theta equal 60 degrees. Here also theta equal 60 degrees. What is this theta? Dihedral angle, right? Maximum space is there in between two hydrogens. Even in between sigma bonds also maximum space is there. Least repulsions. Okay. Two words you have to remember, that is torsional strain and steric strain. Now you take one example, that is butane. If you take butane ka Sahar's projection formula you can write like this. I am taking second and third carbon. The first carbon is one group and fourth carbon also taking as a substituent. So in the Newman projection formula I can write like this. The second carbon, this is the third carbon. Second carbon attached one methyl, third carbon also attached with one more methyl. So total 1, 2, 3, this is the 4. Now exactly the bulky groups, exactly backside is there, that is fully eclipsed. Fully eclipsed. Here with 60 degrees, it is the last time we call this is the staggered. Okay, but here two types of staggers are there. That's why one more, of course, first of all staggered. So another name is there for this, gauche. What is that word? Gauche. The spelling is gauche, but the pronunciation is gauche, or gauche. Okay, it is a when 60 degrees is there, gauche form. Then again it is eclipsed, but eclipsed means again already eclipsed came, so it is fully eclipsed. It is partially eclipsed. Partially eclipsed. So it is already staggered. Staggered word already came. So this another name is, we can say, ante. Okay, fully staggered I can say naito ante. Ante staggered or ante. Ante means exactly the bulky groups are maximum distance quite opposite with 180 degrees. Which one? Bulky groups. Right? The bulky groups are with 180 degrees. This is one type of staggered only, but in the staggered two are there, so it is completely anti-position. So that is anti-staggered or only anti. Now if we talk about stability, you can see least repulsions in the fourth position. So fourth is highest stable. This is highly stable. This is highly unstable. Highly unstable. Why? Completely full repulsion. Methyl, methyl, bulky groups are near. Okay, these two are in between. Of course, in between here, at least some eclipse nature is there here, is staggered. So 2 is more better than third. So highest stable, fourth, then second, then third, then first. Okay, next. See, same energy diagrams we can see here, fully eclipsed, that is highly unstable. Okay, that energy level 19 kilojoule per mole. Okay, if you rotate 60 degrees, so Gaussian form, it is Gaussian form, and here also Gaussian form. These both are same energy levels. See here, methyl methyl repulsions, methyl methyl repulsion remaining, hydrogen 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 same. So right side 60 degrees and left side 60 degrees may we are getting same energy level configurations. Okay, then again if you rotate one more 60 degrees, okay, you are getting again eclipse. Okay, this is also known as partially eclipse or eclipse. So here again methyl and hydrogen repulsions are there. First here big groups like in big and smaller. So will be unstable, so highly energetic. But compared to fully eclipsed, this one is little bit stable. Then again if you rotate one more 60, exactly the bulky groups are exactly opposite. Okay, so means from starting say if you take this the first one here with 180 degrees, after 180 degrees that is forming more stable configuration. Exactly here also more stable configuration. This is also known as anti-configuration. This one is the Gaussian, right? Energy levels both are same. Now here some 2-3 examples we have to discuss. 99% antipositions are more stable. Okay, so if you take what is this structure, CH2OH and CH2OH glycol. Yes, it is a fully eclipsed. It is there after 60 degrees Gaussian form I am writing here. Remaining all are hydrogens. Then again 60 degrees. So I am taking directly 120 degrees. Suppose if I write here OH and OH, then H. Now you tell me which is the more stable, 1 and 2 and 3. In generally क्या होता है? Anti is more stable. This is the anti. This is the fully eclipsed. This is the Gaussian. Right? So which is more stable? In generally, anti is more stable, but is a bit of the poison. So here, due to the hydrogen bond, due to the hydrogen bond, Gaussian is more stable. Gaussian is more stable than anti than fully eclipsed. Fully eclipsed. Suppose partially eclipsed is there, here it will come. Partially eclipsed, here it will come. Partially eclipsed. Okay. Next. So here note point is whenever hydrogen bond, intramolecular hydrogen bond, intramolecular hydrogen bond is there, then Gaussian is more stable. Gaussian is more stable than anti. Okay, but you have to know that when the intramolecular hydrogen is forming. So you know that in the chemical bonding we learn hydrogen bonding. One is fixed. Suppose OH is there, the other group it may be OH, NH2, okay, even C double bond OH, carboxylic acid, like this. The one carbon and the second carbon, if any one of these groups is there. Hydrogen bond, you have to know that hydrogen bond. How the hydrogen bond is forming? Hydrogen bond formation in between hydrogen and other more electronegative atoms like fluorine, oxygen, nitrogen, and okay, these are the more electronegative atoms. The condition is this hydrogen should be connected with again more electronegative atoms. Okay, in this condition hydrogen bond is forming. Whenever hydrogen bond is there, then Gaussian is more stable. In remaining cases, anti is more stable. Okay, and if we take cyclohexane, in the cyclohexane also showing this conformational isomerism, that is one chair form and board form. We'll discuss. So chair form, see this is the chair form. How we will write like this. This is the chair form. Okay. So chair form is stable conformations. Stable, and one more is there, board form. So in the chair form, here two things you have to know, that one is axial hydrogens and equatorial hydrogens. So axial hydrogens is exactly perpendicular type, so more strain is there in case of axial. Equatorial is away from this main structure, so less steric hindrance, that is more stable. So in case of the cyclohexane, 6 hydrogens are equatorial, 6 hydrogens are axial. Okay, so how to know this? See, in this structure, the above carbons means this one, 2, 3. These are the above carbons. In this above carbons, the upside hydrogen, general representation is upside hydrogen is axial. Axial. Okay, axial position may more repulsions are there, that is less stable. So the below carbon is the below carbon, below downside, down carbons, downside is there, again those are also hydrogens, downside is there, hydrogens. If you understood this clearly, then the remaining are equatorial hydrogens. Down carbon, if it has upside hydrogen, that is called equatorial. Okay, upside carbon, if it has downside hydrogen, that is equatorial. Okay, so now in case of boat form, boat is just like you can see, this is the boat, here upside, here it's upside, this remaining is the plane, right? So it is the, you can see in the another form, here all groups are in the eclipsed, all groups are in eclipsed. So more steric, more strain is there, therefore unstable, therefore unstable. So here one is eclipsed is there due to that, and as well here these two hydrogens are there, these two hydrogens are known as flagpole hydrogens, flagpole hydrogens. This first carbon and this fourth carbon, 1, 2, 3, fourth carbon hydrogens, these are also steric hindrance is there. So due to two reasons, first of all these are in eclipsed form, and again this two hydrogen repulsion also is there. Now for the stability, this cyclohexane, it may get into flipping. Flipping. ये flipping में क्या होता है? Flip. The flipping, axial, in the flipping, axial becomes equatorial. Axial becomes equatorial. Okay. So you can see here A dash is there. Here you cannot understand. I will give you this one is a better. So here axial methyl group is there, here after flipping this equatorial methyl. So equatorial is less strained, therefore stable. So now question is, sometimes they'll ask methyl cyclohexane stable form, write the stable structure. So like this, Okay, the cyclohexane, whatever you are thinking like this, it's not this form. The cyclohexane is existing like this chair form. In this chair form, if methyl group is there, the methyl is always in the equatorial position. Okay, in the equatorial position, that is more stable. Of course, axial also is there, that is very very less percentage. Out of 100 molecules, only 5 molecules are with axial, the remaining 95 in equatorial, like that. Now, so why axial position may that is unstable? 1 comma 3 diaxial repulsion. See here, flagpole hydrogen in the last time we discussed. So similar to that, so this carbon methane is there, methyl group. This hydrogen and these hydrogen, these are axial hydrogens, straight perpendicular. So here repulsions are there. But in case of equatorial, so completely this group is away from the main group, main chain. So here repulsions are there, but these are only hydrogen hydrogen repulsions, that is not considered much. Okay, so this one is more stable. Okay, and if you want, I will give one more example. Suppose here, what is this? Tertiary butyl is there. So tertiary butyl is axial and methyl is equatorial. Equatorial, it is axial. So which is the most for this compound you write stable conformation or maximum existing structure. So here it will be flipping. Flipping means this A and B I am writing. This A position going up, like this you have to write. So this is the A position, this is the B position. So the tertiary butyl is अभी भी upside है. Okay, here A position is upside is there. So now it became axial, it became equatorial. So okay, this is the more stable. Okay, suppose if it is 60% is there or 70% is there, it is 40%, like this. Okay, so like this it is a flipping. Always big group, note point is big group should be in axial position, equatorial position, equatorial position, right, to avoid the strain. And one more information, suppose if I take axial position, one R group is there, equatorial position R. Okay, sorry, for this I can write it flipping. Yes, erase. For this flipping, this A position and B position are, this is the A position, this is the B position. So obviously it is a more stable, more stable. Now if I take R equal to hydrogen, R equal to hydrogen, then same 1 is to 1 ratio, 1 is to 1 ratio. Suppose if I take R equal to methyl group, okay, it is 1 is to 18, 1 is to 18. If suppose if I take R equal to ethyl group, then 1 is to 23. If I take isopropyl group, then 1 is to 38. If I take R group is tertiary butyl, in the last example I took that. So 1 is to 3800 times. Okay, that means this much. If you take 38,000 molecules, out of 38,000, one molecule is in axial position, remaining 38,000 means almost 99% like that. That is exists as equatorial position. It is equatorial. This is the axial. Okay, but